Okay, I think we're going to go ahead and get started. Welcome, everybody, and thank you for coming to this morning's Berkeley Research Computing Town Hall. We want to talk to you today about this great new service that's going to provide free computing to faculty in support of your research. My name is Patrick Schmitz. I'm Associate Director of Research IT. I'm going to talk to you a little bit about some background for the program, and then we'll have Greg Kurtzer and Krishna Muraki who will explain some of the details of how you can use this, how to get signed up, and how we'll work with you. So some of you may not have heard of Research IT. We're a unit within the Office of the CIO. Our mission is to advance research on campus by providing innovative and effective, cost-effective services around everything from computing to data management and others. Some of the current programs include Berkeley Research Computing, which I'll talk a little bit more about, Research Data Management, which is a new partnership between Research IT and the libraries to look at some of the gaps and issues around data management on campus and provide some services to both guide faculty to what's available now and to look at where we need to fill some of those gaps. We have a digital humanities program that we're working on with the Dean of Arts and Humanities, Dean Cascardi. That was funded by a large Mellon grant, and we work with faculty and graduate students on campus to apply some new techniques around computing and text analysis in the humanities. And then finally, a program that we've been running for a long time, Museum Informatics, supports museum collections with collections management software as well as application development to expose and analyze those collections. Now, we run many of our services as a result of input from faculty. We work with the academic side of the house to determine what's really needed. And some of the things that we identified in a benchmarking analysis we did a couple of years ago now that we look at now as areas to explore include quantitative and qualitative tools for data analysis. Now, there's folks providing this now. For example, the Social Science D-Lab does this. But we're also looking at other ways of providing these and making them more available to people. Data visualization has become a hot topic across the spectrum, from the sciences through digital humanities, and it's an area that's getting a lot of attention at this point. We do some research application development, and that's an area where we've been talking to faculty about how much need there is there and ways that we can support it, recognizing that central IT unit is often fairly expensive in those projects, but we can still help guide some of those projects and provide more sustainable solutions with the kind of projects that you're doing for your research. Software licensing and distribution and some of these other things, web publishing and collaboration, these are some other areas we hear about a lot that we look at. So how did we get here? About 2 years ago now, Elliot Quatert and about a dozen other faculty wrote to the Vice Chancellor for Research basically demanding that we do something about research computing on campus. We were one of the few R1 universities that had no institutional support for research computing. This was causing us problems with faculty recruitment and retention, as well as putting us at a disadvantageous position with respect to winning grants. So the Vice Chancellor for Research worked with the CIO, Larry Conrad, and later in a partnership with the Chancellor to put together a program that supports research computing on campus. We initially built out an institutional cluster and added to that to build a condo, and I'll talk a little bit more about that. We ended up running a lot of forums before we built that out. We didn't just go ahead and dive in and just start building an HPC cluster. We talked to a lot of faculty around campus, and that led to a lot of discussion about what all was needed beyond traditional scientific computing. We also did a survey of our peers, looking at what other campuses do around research computing and talking to them about what had worked and what didn't work. And we learned a great deal about that. And that informed the decisions that led to the development of the program. So Berkeley Research Computing, or BRC as we often call it, is composed of 4 areas of service. The first to launch was the Condo Institutional Cluster, which we've called Savio. That launched about a year after the letter from Elliot Quatert and others went to the Vice Chancellor. This was launched in partnership with the High Performance Computing Services group at LBNL, who work with us actively, and the guys that are going to be talking today are in that group. So that partnership was essential, and that sort of set a pattern for how we do a lot of our work, which is in partnerships with various folks. The initial hardware investment that was made with funds from the CIO was more than doubled by Condo contributions in the first year. And That was a big success in demonstrating the interest and the need on campus. In a condo model, for those of you that don't know, faculty can use research dollars to buy hardware, primarily compute hardware, and contribute that into an infrastructure that then is subsidized and maintained by the campus. So you don't have to buy all the racks and the cooling and the power and the shared storage and a lot of that stuff. We provide all of that, including a new storage array that adds a petabyte of fast parallel storage to the system. And in exchange, when you're not fully utilizing your contribution, when there's spare cycles available, we make that available together with the pool of compute that's purchased by the institution to support other faculty and graduate students doing research on campus. And that's part of how we provide the faculty compute allowance that we're going to be talking about today. A second area that came up in our discussions with faculty was cloud computing. Not everybody needs a traditional scientific compute cluster. A lot of people are looking at public cloud, asking about private cloud and what might be done there. And there are a lot of algorithms that scale better out in traditional cloud environment than they do on some of the clustered environments. The question then was, well, what should we do? Should we build our own private cloud? That some people thought that would make sense, or a hybrid cloud. We were very cautious about investing in that. And the discussions have led to a services proposal that we're currently reviewing with the campus that identifies several areas of consulting and some means of using some of the institutional resources in more non-traditional ways to provide access to that. That's a proposal that's out now. We've already started providing some of those consulting services that allow faculty to more easily get access to, find grants for, and then deploy cloud services either in their research or in support of cloud-based learning or cloud compute in support of learning. Now, in addition to the sort of large compute areas, there were a lot of folks on campus, in particular in social sciences and some humanists, who didn't need anything like traditional high-performance computing. In fact, for them, some of them quipped that high-performance computing was going to be something bigger than their laptop. They really just needed to run software that they were using now in a more powerful environment. And we came to call what was needed there virtual workstations, or these analytics environments on demand. And that's an area that's still in definition right now. We've got a new architect that's coming on that's going to start moving that ahead fairly soon. And we're working closely with the D-Lab and the library and some others that are already doing experiments in this area to see what we really need to provide. Now, all of these services are great on their own. There's some nice hardware there and some expertise, but clearly we can't just toss it over the fence and say you're on your own in terms of using this stuff. And so a major part of BRC is the investment in consultants and providing that consulting to campus faculty to ensure that you can actually make effective use of the compute resources. And so we think that's a really important part of it. It's also why we put it at the heart of the diagram. In addition, however, it's not just our consulting. Everything that we're doing exists in the context of campus centers, campus research groups, and a lot of expertise that is out there now. And so we understand very much that what we're doing is in networking with the campus community. And so the community is a big aspect of that. Part of the way we recognize that is that we do actively facilitate that kind of community. So some of our investment is in bringing together the different folks that are doing this kind of consulting. In January of this year, we ran a consulting summit that brought people from all different libraries, from centers all over the campus, who are doing consulting in support of research to talk about how can we work together more effectively, either doing referrals better or actually sharing information about the different services that are available across the campus so that we can get better answers more reasonably to faculty. And that's pretty successful. We've had a lot of people with a lot of enthusiasm about that. It's one of those things that in general, people are willing and interested in working with one another, but they just don't have the time to do it. That's where a central group like Research IT can help. We can provide that little bit of investment to do the facilitation of the networking community and really make a big difference. Now, when we talk about the services, we've got these different services available, we recognize that it's not always the case that you fit neatly into one of those throughout the entire research phase. And so we talk about this idea of mobility of compute, which really brings mobility of data along with it. But the point is that at different phases of your research, it may be appropriate to be working on a powerful workstation and to move across these different environments to cloud or to the high-performance cluster and back, depending upon what you're doing with your data. In addition, many people are making use of other national and public infrastructure, and we recognize that that's an important piece to recognize. And so a lot of the decisions we make about what we're deploying locally, as well as the consulting that we're doing, is geared towards making it easier and more effective to be mobile across these different environments, and recognize that as you move across the different phases of research, you may go from a workstation to a local cloud out to public infrastructure, or you're using the local cluster to on-ramp to something like Exceed or NERSC facilities. So we're very cognizant of that, and we think that there's some areas where we can be innovative and make that a lot easier to do, both on the compute side as well as on the data side. And that's an area where, again, working with partners like Chris Pachorek at the Statistical Computing Facility and some others, looking at what can we do to make these kinds of models for how you deploy your research software, make them a little bit easier to manage across these environments. So the last thing that I wanted to mention here is emphasizing this partnership. I mentioned community a couple of times, and you'll hear us talk about that a lot. But these are some of the folks that have been really important in helping us to define these services, to deploy the services, and as well to talk to faculty and work effectively with faculty on how we're actually going to make them effective for people. So that's basically what I wanted to say, just a little bit of context there. I want to get to